Alright guys, I'm back and let's continue this. So now we're going to try to begin to get the incrementation of generations, and then after that we're going to begin to try to get the mutation going. And once mutation is done, that's where most of the training and all that part of this comes, where the genetic the real genetic algorithm part of this begins to come in during the implementation of the training and of the mutation. Alright, so we're going to start off by trying to figure out, we're going to try to implement death for these fishes. Okay, so when they touch a wall, we want them to actually just die, but we also want them to let the G manager know, the genetic manager know that they died and what index their brain was. So the genetic manager will know what their fitness value is and all that. So right here, I'm sure you guys can't see it, but even if they touch the wall, nothing will happen. So let's get that going now. We'll go to our code, and in our fish controller, we're going to implement a onCollisionEnter function. But before we implement an onCollisionEnter function, we're going to implement a death function for our fish. So what should happen when our fish dies? Well, one, the fish is going to have, the game object should be destroyed. But two, the fish's brain index and its fitness should be given to the genetic manager. Alright? So in this, up above here, right in between brain index and in between the ray distance, we're going to implement a private float overall one second, guys. Alright, I'm back. So we're going to be doing the overall fitness. Okay? And this overall fitness is our fitness for the fish controller. Right now, we're still not going to implement the fitness, so it's always going to be 0. But in the future, once we do implement the fitness, it's going to slowly increment based on how we reward the fish. So in our system, our reward is how much the fish grabs the food. Anytime the fish grabs the food, we increment the overall fitness to be +1 or +2, +3. And so the more food it grabs, the higher overall fitness it gets. And then the genetic manager will know which is the best, which of them have the best fitness, basically. And so we know which one to keep, which are the 5 best to keep, and which are the 5 worst to leave, or whatever numbers you guys decide to use. So we have the overall fitness set here. Then we have to create a function for our death, so that when the fish dies, it passes the overall fitness and the brain index to the genetic manager. So and within that, we're going to do so we want to find the neat genetic manager, because we only have one in the scene. So we can easily find it using the find object of type. And then within this neat G manager, we're going to have a function called death. And this function is going to be called whenever one of the fish dies, whichever fish does. So the depth function in the G manager is the function which will receive the my brain index and the overall fitness. This function has not yet been implemented. We are going to move over to the G manager to create it. Do not worry, guys. Right now we're just writing it because we know that we are going to need a function in the G manager to manage death. So, but not only is that, so once we do pass the my brain index and the overall fitness, we can go ahead and simply destroy this game object. And that will be our death. Whenever anything, whenever this function is called, this line will send the brain index and the overall fitness, and then the game object will destroy, simulating death. Alright, so now we're going to come back to our neat G manager, and we're going to implement the death function. We're going to do public void, public because it's being accessed outside of this class. And yeah, so public void death. And in this, we're getting a float of the fitness. And then we're also getting an int for the index. Alright, and simply... yes. This part is also interesting. So, where do we store the fitness? We could create another array of fitnesses. And so we could just match the index with all three arrays: the array for the body, the array for the fitness, and the array for the brain. However, when we actually think about it, this fitness value is it's actually defined for each brain. The fitness is the measurement for the brain itself. It's not the measurement of the body, nor is it something that should be contained within the genetic manager, but it is something that is literally in neat. It is something that should be attached to the network itself, because the fitness is something that is going to define the network and how the network gets mutated, or if the network gets mutated or not. Okay? So instead of having a 3 different lists in the neat G manager, we are going to move to the neat network. And in the neat network, we will create another public float and call that fitness. Simple as that. Okay, we don't have to put that in the constructor or do anything with it, because we will assign it in the whenever death happens. Okay, so before death, there is no fitness value for the function, but after death, there should be a value. So if you ever get null for fitness, you know that the for some reason fitness was accessed before all of the spawn bodies die. So this also helps us know when errors occur. So now that we have the fitness value in the neat network right here, we can go to our neat G manager and we go all neat networks on the and we can get the one that matches to the index that got passed. Dot fitness equals fitness. Alright. So this will set the fitness of the neat network, which is stored within the genetic manager. Alright, so each neat network in the genetic manager will have its own fitness. Now after the first generation, each the best will have their old fitnesses. So we can actually keep track of whether the best the 5 best that we kept, whether the fitness of them have increased or decreased. But since there's no mutation happening to them, their fitness should stay the same. But anyways, yeah. And that's our death. Basically, we're storing the fitness within the index. So in future, we can sort the neat networks based on their fitness. Okay. So we will have to write a sorting algorithm to sort the neat networks so that they go from the highest fitness to the lowest fitness at the end of each generation. But for now, let's get done with implementing death. So we have death done for the neat G manager, or what the logic is for the death in the neat G manager, and we have a function that calls that death and passes it the variables. All right. However, we still do not have the collision, because without collision, there was no way that the fish will know that it actually hit a wall or not. So now let's implement the onCollisionEnter. This is also a Unity function. Collision and wait. Before we enter this, before we do this, let's first save and see if there are any errors, which I'm sure there are. All right, void could not be found. That makes sense because that should say void. Let's fix that. All right, next, Niji manager could not be found because I'm missing an A. Let's go back there, Niji manager, and go back. Everything is looking good. These are just warnings letting me know that some variables assigned but never used. They will be used, just we're not there yet. And everything looks like it's running. However, there is no collision still because we did not enter the we did not create the onCollisionEnter function yet. So let's get to that. So it is private void onCollisionEnter and get the collision object. Alright, and then now we can use the tags that we already set up, the tags that we used right here. So we could just copy this line right here, or we could just write it. But this time we do collision dot. Over here we do hit dot transform dot tag because we get a hit. Over here we do a collision dot transform dot tag because we get a collision that stores our object. Okay, so if we get hit with a wall, we want to set our overall fitness to be 0, because if we hit a wall, we know that the network is not fit at all. So now this is a little harsh. You might want to like divide overall fitness by 2 or do something like that. But for right now, I am going to leave it at 0. All right. And then we simply call the death function, which will destroy the game object, and call the death function for the neat G manager, which will store the brain index. Please make sure to set the overall fitness to 0 before you call the death function. The death function should be called after any changes to the fitness. Okay, so if you want to calculate fitness or add fitness, anything, you want to this line needs to be called at the end of the life, and nothing should be done after this line. No changes to the overall fitness should be made after this line. All right. So when now if anything hits the walls, death should be called. So to make sure that is happening, we will do a debug.log statement, and we will do fish died. So meaningful debug statements. Alright, let's press play and see that fish did not die. You see how it's going over? I know exactly why that's happening. Because we still have not added a rigid body to our fish. I believe in an earlier video I stated that if these fishes do not have rigid bodies, they're not going to collide with the walls. The fact is that without the rigid body, it just doesn't know that the collision is happening. We need to let the Unity engine know that these objects need to use their physics and stuff. So what we'll do is we'll go to the prefabs, click on fish, scroll down to add component, and we will add rigid body. Now the rigid body is added, we put mass to 0, which will give you a weird number, whatever. Use gravity, we turn that off. We do collision detection, we put change it to continuous. And then on constraints, we constraint all of the axes. We do not want the rigid body to allow any movement, because all our movement is handled through script. So let's press play and see if everything is working. It is still moving, and now we get the log statements of fish died without any errors. So the fishes are dying now. And it's pretty nice. Let's make sure that the fishes are dying. Let's actually try to see one when it touches a wall. These ones will. And that's gone and that's gone. We don't see any fishes floating. Everything is looking good. We have the simulation of death. Alright, however, we do not know if our fitness is being stored yet, or if our fitness value is being set properly, because we do not have any fitness. So we're going to have to fix that in the future, but I believe it's about time that we get the food in and begin to add survival. Okay, we still do not have generations, but we have death. And now we need to know what, through one of these fish's life, what are they supposed to do? So before we add a second generation, I think it's a much better idea to add food and add the fitness for the food. So if fishes get food, their fitness will increase. So let's get to that. For the food, we have already created a food object, which is right here. Let's add that to the scene. Take a look at it. Click F to zoom in on it, and yeah, it's looking good. It's in the right position. Everything is fine. We're going to look through and see if it's tagged. The food is not tagged properly. It should have the tag of food. So let's add that. Do not just click on here and add the tag. Go down to the prefab. Click on the prefab. Open the prefab. Now go on tag and add tag. When we add the tag, click on the add button and click and type in food. Okay, now click on this food object to the left. This is not your normal hierarchy. We're still in the prefab. We're still editing the prefab. So click on the food, and now you see it's still untagged. When we create a tag, it does not add that tag to the object. It just adds the tag to the list. So you got to go back and then tag the food, and now we have the tag of food, and our prefab is ready, so we can back out right here. And we can clear that because that's not a important error, and we can shift delete this. Alright, so now our food is there and our fish is there. Everything is looking good, and we even got color on the prefabs, which is awesome. So for our food, we also want it to spawn. Okay, we want our food to, just like fishes are being spawned, we want food to be spawned, and we want to make sure there's always food in the scene for the fish to get. so that the fish can potentially survive forever. Okay, we don't want to cap off the fitness level of the fish by not giving enough food. Okay, we also do not want to give too much food so that we actually know that training is happening. The ideal case is to slowly remove food to the point where there is just a limited number of food, and it causes some type of competing behavior between the fishes that are alive. So between the 20 fishes that we have, we want to simulate co-evolution through competition over this food. Alright. Now, so we're going to go to our scripts, and we have our script. We're going to create a folder and call this neat. Just call it neat, right? And copy and paste. Well, just drag and drop the 4 scripts we created into this folder. Alright. Now we're going to create a new folder. And this folder, we're going to call it food. So our scripts for our neat will be separated from our scripts for the food. Mainly because the neat is not actually dependent on the food. And even right now, the neat fish cannot even see the food yet. Right? They only have sensors that can see the wall. So they're not connected. They shouldn't be in the same folder. Alright. So let me see what my naming is for the food stuff for this fish. Alright. So we're gonna create a C# script, and we call it food controller. Because while nothing is really going to happen to the food, we still in the future we might want it to add movement to the food so that we can get chasing behavior. Right now, we probably won't do anything with the food controller except maybe set it up. In the food controller, we also have the function for the spawning of a single food. So whenever a fish will touch the food object, it will send a signal to a food manager to spawn another food somewhere. Okay? And this way we will have food spawning constantly over and over. So the reason why we call it a controller is because in the future we might want to add fish movement. But for right now, all it does is let the food manager know that it should spawn another piece of food somewhere. So we'll go to food controller. We'll get rid of all this for now, and we'll simply write a function, public void spawn single. Man, make sure it's public so that the fish controller can call this spawn single food. And this single food function will tell food manager to spawn single food. Okay, this function is not created yet, nor is food manager defined. So up on top right here, we will do we will define the food manager. Alright, so that's the food controller class. It's a very simple class, which is why I started off with it. But now we need to create the food manager class, which is where all the spawning of the food and everything is actually going on. So the food controller class is done. We'll now go to Unity. Oh, let's see what errors. Well, yeah, food manager is not created yet. Now we will create a C# script and call this food manager. And with that, we have to now create the spawn single food function within the food manager. So we go to Visual Studio Code, go to food manager, and now we add the function. We have to make a public void because it's being accessed by the food controller. Copy the name, which is spawn single food. Ooh, what's going on? Alright. And paste it right here. So spawn single food, and it will spawn a single food item. Alright, but we don't even have the creation of the food yet. But for right now, let's go ahead and create the spawn single food function. Then after that, we will create the function that in a loop creates how much food initially is on the map. For this is similar to how we spawn the fish, in the sense that we get the vector vector 3 position from the viewport of the camera. So we want to keep it at the same z value that we had the fishes being spawned at. So we had that set to 20. Please set that to whatever you thought was the good value. But I hope you guys just followed along, and it should be 20 if you followed along. Now we get the camera viewport to world point. And we pass it the position. So we get the random position similar to how we got it for the fish bodies. Now above we will have to specify the, well, let's do that right here. Comment that out. We'll go up here and we'll do a public game object. We'll call it food prefab. Alright. And now let's come back down here and change this. So we're going to call this local food because it's a food object that is being spawned. And we will then instantiate it. Instantiate. Then we give it the food prefab, the position, and the transform dot rotation, the R being lowercase. And the transform dot rotation is gotten from the object that the food manager is attached to. So whatever the rotation of the object of the food manager, that's what the rotation of the food will be. And since the food manager will be set to the default transform, so everything will be the default rotation. Now we have the local food instantiated, but there is one problem. The food manager is not set, right? We have this public, but the food manager is not set. So an easy thing to do right here is whenever an object is spawned, we simply set the food manager over here. So local food dot food manager equals this. All right. So this is going to be this script is going to be attached to an object in the scene, and that object is going to be spawning fishes, right? So whenever a fish is spawned, that object just lets the fish's controller know that I'm the one that spawned you. So that's why it gives itself this. It gives the reference to this script that's going to be in the object. I hope that makes sense. But yeah, so this will store, this variable will store whatever manager, whatever instance of the food manager is spawning objects in the scene. Alright, so this now lets us spawn a single food whenever a fish is whenever fish eats the food. We don't have the collision to the food yet. However, this will allow, whenever it does happen, this will spawn a new one. So we have the spawn single food and that. And next, for the fish controller, for the fish manager, we're going to do the instantiation of the food. So on top, let's go ahead and begin to define some of the variables we're going to use. We're going to use a public int food count, which is basically how many foods we're going to want to spawn. This could be anything from 100, 500, whatever. It just depends on how big your scene is and how big you made your camera. Next, we're also going to keep a list of all the foods that are spawned in our scene. So we always want to know all of the foods that get spawned, but this might not be used for now, so let's comment that out. That's not a good way to do this. Here, why don't we not put this in for now, and we will add this when we need it. But for right now, we'll take that out. Now, public int cur alive is important because we want to know how many foods are actually still in the scene. And private bool repopping equals false. If you ever want to repopulate all of the fish food, let's say a new generation happens of fish and we want to start off with a fresh number of food, we will have to destroy all the food that has been spawned and then repopulate a set number. Okay, and because spawning eventually, when fish these fish will get really good at training. They will get really good at eating food, let's say in one area of the map, and then when the next generation gets created, all the food will be put into the area where the fish weren't trained for. Now, this might seem like a good idea. However, it's better to reset the food every time so that we have a blank slate for each generation, so it can steadily increase instead of adding a variable to the environment. Alright, so we're going to reset after every generation, but for right now we just want to get the spawning going. So we're going to get rid of this and we're going to change the start to an awake, and in the awake function we want to set the current alive equals to food count. Because to begin with, we're going to spawn the food count number. Okay, so we actually will be adding the foods object right here. Because, and we might as well just get everything out of the way right now. Okay, and then we have to instantiate the foods object to exactly to the food count that we have. So how many food objects we start off initially. And then we have to call the function for spawning the actual food. That function will write right above the spawn single body. So public void spawn food, and then right there we will add a for loop for the spawning of the food. And now we spawn foods almost exactly the same way that we did over here. Actually, it is exactly the same way. So we will copy and paste that. All right. So once our single food has been spawned, we have to change, however, this right here. Okay? So since we're spawning in a loop, we no longer have to we already have the foods game object, so we can simply do foods I equals the instantiated game object instead of creating the local food, which is right here. Right? We can populate it in the list. And you might think, why isn't it being populated into the list when we spawn the single food? Well, we take care of that in the fixed update, which we haven't implemented yet, but we will get to that. So right here, we're going to do foods I dot game object dot get component food controller, and then the food manager of that food controller. So over here we have the local food, which we already have the game object. However, over here we have to get it right here, and this should actually be lowercase. Sorry about that. This is not going to work. Yeah, this is not going to work right here. This line should actually be local food dot game object dot get component food controller dot food manager. And now this should work. Sorry about that, guys. You know, just writing this. Yeah, so caught the error before it happened. That's good. But this is looking fine. Go to controller, food manager. Yep, food manager. Yep. I guess we didn't close somewhere. Let's see what's going on. Where did we forget to close? Right here. Okay. We didn't finish it. There we go. So now that that's closed, let's see what other errors came up. Is a method which is not valid. Looks right here. Add the function. Yep. There we go. That looks good, everybody. Let's get back to it. So our spawn food function is now done, and our spawn single food function is done. However, we are still not spawning any food. So in the awake function right here, we want to call the spawn food function, which will spawn our initial food and also populate our foods list. Next, let's change this to a fixed update, so we have updates on a fixed length. And now we will first begin by seeing if foods are being spawned. It looks like there are no foods in the scene because we do not even have the manager set up. We didn't pull it into the scene. So over here now we will we will actually set the object up for the for the food manager. All right. So we create an empty, and in the empty we call this food manager, and the food manager will add the component food manager. There we go. For in the food manager component, we go to projects, we go to prefabs, grab the food prefab and drag it to the food prefab slot right here. Okay, we set the food count to be 20 because we have 20 fish, 20 food. We will actually start this off at 50, but for right now we will make it 20. And then current alive, that we will see change in the fixed update. Right now this will not change, this will remain 0. And we see 2 fish, 2 food. I guess that's good. I don't really understand why only 2 of them were spawned. There is an error. Object reference not set to an instance of the object. It seems that when we spawn the fish, we get this error right away. So because we do not have our fish prefab set up. So we spawned a single food, but right when that food gets spawned, we get an error. That is because our fish food does not have any food controller connected to it. So what we will do is we will click the food prefab, open that prefab up, then go to your scripts, go to the food folder, click on the food controller and drag it onto your food prefab. Some reason that didn't add, so let's try again. There we go, we got added right here, you can see that. And yeah, now that we have that, we can back out of here and press play again. Beautiful. We can see that all of our food is being spawned, our fishes are moving. However, we still do not have any collision between the food and the fish, which is to be expected because we have not added that food to the on collision enter yet. However, we see that food is being spawned, which is great. Another thing to notice is that our current alive is set right now. Alright, so right now it's set because this is the first generation. However, once we add the collision, you'll notice that current alive will not go up or down. It will just remain the same always. So let's we'll first add the collision, and then we will add the current alive, making it go down or up. Okay. So we come back to our food manager. We come back to our Visual Studio Code, but now we want to go to the fish controller. Okay, in our fish controller, scroll down to the on collision enter function, and in the on collision enter function, give me 1 second, guys. Okay, in the on collision enter function, we want to add the tag for the food, and we want to change the overall fitness once the fish collide with the food, and then we want the food to call a death function. Okay, so we want the food object to die as well. So right here we will do else if collision dot transform dot tag equals food, we will now begin to add the code for what will happen when the food gets hit. One of the things is that a new food object should be spawned. We get component of if it's a food object, we get the component food controller. And in the food controller, we call the spawn single food, which is the public variable, which is a public function that attaches the food controller to the food manager. And then the food manager spawns another food object. Then we destroy the collision object. Now that basically that spawns a new food object and gets rid of the food object, simulating that the fish just ate a food. However, to actually give meaning to the eating of the food, we will change the overall fitness. In the future, the overall fitness will change by energy, right? So the fish will have a given number of energy, and every time food is eaten, energy is increased so that the fish doesn't die. And the more the fish eats, the more the fish lives, the more energy is used. Okay? But for right now, we will simply manually affect the fitness, which is going to just be plus equal 5. So we'll add 5 to whatever fitness we have. Fitness is 0 up on top, so we simply are going to add 5 to it. And with this, now our fitness will go up, and fishes will eat and destroy food, and at least it will look a little bit like what we had in the beginning when I showed you guys the example project. Oop, errors. Let's see what we got. This story does not. Okay, I got you. That makes sense. Alright, let's save that, see if that's good. Alright, to also see so we know that cubes are actually dying, we'll add a print. So on the collision, we'll add a debug.log, we'll just copy the one that was above. Fish ate food. Okay, so whenever we see this, we know that at least the destroy collision, the game object, the function was called. Fish ate food, fish ate food. Oh, I didn't actually see any fish eat any food. But it says that it did. It probably happened somewhere. And I just missed it. So let's try. Yeah, right there the food disappeared. And then another food brick respawned. Good, good. You're so close. It's right there, guy. But anyways, alright. So fishes are being spawned. Food is being spawned. Food is being eaten. Food is being destroyed. Everything is looking good. And fishes are being destroyed. So things are looking great. We're doing great. And also current alive is keeping up to 20. This should not be the case. I believe it's staying the same because it's always going to stay at 20. Even if I move it down to 47, it just won't change at all. Because whatever it's set to initially, that's what it will be. And initially, we set it to food count, so it will remain 20. However, this number is not a representation of what's actually happening in the scene. We see that there are foods alive, but there might be more or less than 20 if I count all of these. I don't know for sure. But we know that there's not 81, and when I change it, it goes up to 81. Like, it's not actually representing what is happening in the scene. So now we will make it do that in a fixed update. So wait, before I do that though, let me see how long this recording has went. We're 50 minutes in. I guess 10 minutes we'll get the rest of this food implemented. That's the right word. All right, so let's go back to our food manager. But in our food manager, we are now going to be working in the fixed update function. Okay, so in our fixed update function, we're going to do a if statement. If repopping equals false, and her alive is less than or equal to 0, then we want to repopulate. So repopping equals true. We spawn food all over again. So we'd call the spawn food function, which spawns our food from the beginning. And we then set repop equal to false to happen all over again. However, our current alive will never get lower than 20. It never changes, right? And theoretically, our food should never reach 0 because we keep on spawning a new food object whenever the fish eats a food. Okay, so ideally this never gets called ever. It's there as a safety net. And also when we in the future we can destroy all the food, which it will do, and then once all the food gets destroyed through script, this function will be called. So right now it's not being used to its full potential, but in the future we will implement that. Right now, let's add the next bit, which is to make sure that the current alive value is constantly representing what's actually happening in the scene. So when a fish eats a food, it should go down to 19, and when a new food gets spawned, it should go back up to 20. And to do that, we're going to create a function called current alive, which is going to keep track of how many are alive in the scene. And it's going to return an integer, which is going to be how many are alive. So we have the food controller list. We create a list of food controllers, and we call this local foods because these are the foods that are going to be alive. And we find objects of type food controller. So the find objects of type function will find all the objects of type food controller and return a list of them, which we store in the local foods list. Then we have int alive equals 0. We create a integer called alive and we make it equal 0, and we simply loop through our list. However, that's crazy because all we have to do is, wow, that's interesting, return. All we have to do is return the local foods dot length. I believe it's going to be dot length -1, but we'll make sure right here by also printing. Oh yeah, also debug dot logging the local foods dot length. We'll see if that's right. Ah, we also have to remember to call that function. So we created the current alive function, but we are not calling it. So right here we'll call current alive equals current alive. And that now, every fixed update, the function is being called. So you see we have 20 food. Yeah, so we have 20 alive. That's pretty much perfect. And so we have 20 alive, and whenever we'll have less. Okay, so let's see. We have 20 alive right now. Let's grab the food clones right here. You'll see on the side. Let's grab, let's say, 1, 2, 3, 4, 5 of them and delete them. See, we shift deleted them. We go back to the food manager. Now we see that we have 15 alive. We delete these many. Go to the food manager. We have 3 alive. The food manager is keeping track of how many we have alive. And now let's see if our repopping is working. Let's delete all of them. So we have 1 right there. Delete that. Now we have 2 at the bottom. Delete that. And now we repopped. All of our food is back since we ran out of all the food in the scene. So this is all working perfectly as expected, and it is set up to account for generations. That's looking good. Now I believe we need to add one more thing before we finish, and that is simply to destroy the food. Okay, so we have a way to create the food. We have a way to keep track of the food current alive. Now we want a way to destroy all the food so that after each generation, whenever a new generation is going to pop, our genetic manager can call the destroy food function in our food manager. Alright? Destroy food. And then that will be, we'll do the same thing right here. Just copy this line down over here. I don't know why I didn't just copy and paste, but whatever. Alright, so we have all the food objects that are in our scene currently, and we do a simple for each. For each food controller, food in local foods. This should be local F with a capital. Up here, F with a capital. Let's change that down over here too. And change that down over here too. And then over here, let's change it. Okay. So we changed the F here, 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 and here to capital. In local foods. And then all we do is destroy. We don't say destroy food. We don't call ourselves. It's not a recursive function. We call destroy food. Destroy. Food dot game object. So whatever game object what the food was attached to. And that should be good on the destruction of the food. Okay, I'm a little bit concerned about the food.game object, but I believe when we do find objects of type, that stores not just food controller, but also the game object. Oh no, my earbud fell out. Alright, so that's everything for the food. Next we'll be implementing the energy for the fish, so that the fish, if they survive long enough, they'll die. Like if they live for a certain length of time, a certain number of energy that they have, they'll die. And then we will implement the ability for them to live longer. Whenever they do touch a food, their energy increases. Instead of their fitness going up, their energy increases. And then we will implement the mutation. I guess then after the mutation, that's pretty much everything. After the mutation and the fitness, everything will be done, and we'll be at the end of this. Alright, guys. So I'm going to we'll be at the end of setting up the neat part of this, like setting up the bare bones. We still do not have the speciation. We still do not have the moving guys, the moving sensors. We don't even have all the sensors that we need. So there's still a lot more to come, but we are coming to the end. So I'll see you guys in the next one.